Okay folks, today we're going to look at a statistical process control chart known as a P chart. Now the P chart is a specific type of statistical process control chart that looks at just the portion defective. In other words, on day one we took a sample and we said, okay, 6% of that portion was defective. Day two we looked and said none were defective, so on and so forth. And what we want to take a look at is what portion is defective, whether or not the process is capable of handling the load, so on and so forth. And I'm going to walk you through the steps and explain them as we go. But before I do, I also want to go over some things about why we're doing this in the first place. Now there are several different reasons why we might actually use a statistical process control chart, and all of them are related to one another. Okay? The first one is because we want to monitor and control the processes themselves. We want to know what's going on. We want to know why there's 6% defective here, why on day 2 there was only 0, but if we come down here on day 21, there's 55% defective. Down on day 25, there's 69% defective. That's a problem. If this is a company like Amazon or one of the other like Zappos or something like that, 69% defective means that roughly 70% of all of their materials are going out the door incorrect, and that's just not acceptable. Another reason why we do that is because we want to reduce waste. Let's say you're a company like you're a cabinet maker or whatever. Well, if you could trim this down and you find, okay, there's 4% defective here, 0% defective here, maybe you can get these folks here to train the other people so that they're reducing waste. Domino's Pizza and Papa John's and other places like this actually use statistical process controls to monitor how much food actually goes on a pizza. So they don't want to have too many pepperonis because that wastes money, and they don't want to have too few because they don't want to anger their customers. Another reason is because we want to catch the mistakes early. If we can catch the mistake before it goes out the door, it's only going to cost us about $1 to fix it. If we wait until the end of the process, then it costs us roughly $10. But if we wait until the customer catches it, and then they call us back to tell us we've made a mistake, we not only have to replace it, but we've now angered the customer and taken the risk of actually losing that customer, and that's just not something we're willing to do. So this gives us the 1-10-100 rule. Catching it early costs us $1. Catching it at the end of the process costs us $10, and if we wait until it actually goes out the door, it'll cost us roughly $100. Finally, we want to know if our process is capable of handling the load. It may be that our process is just too tight, or we want to know if the controls, maybe we have it set in a position where we can't do the job. For instance, let's say I want to ask you to cut a ream of paper for a copier machine. Well, in order to make your quota, you have to cut that paper to the exact standards. You need to make sure that it's exactly 8.5 by 11 so that it'll fit in the copier, and it can't be inaccurate. It has to be within plus or minus 1/1000th of an inch. And oh, by the way, I want you to do it with a ruler, a pencil, and a pair of scissors. In order for you to make any money, you've got to cut 2,500 sheets of paper today. Think you could do that? Probably not. It's just a lot. And so that's not something that you and the process are capable of doing. It has nothing to do with your skills. It just, it's a pair of scissors, for crying out loud. So we need to put that in a machine and let the machine press it and cut it for us. Now, in order to get all of this done, let me take this out of our way. In order to get all of this done, the first thing we need to do is find our P bar. And P bar stands for the portion defective average. Anytime you put a bar over the number, you're looking for the average number. So in essence, what we're looking for is the mean or average portion defective. So let's go ahead and do that. We're going to say equals average of the portion defective. So that's going to be B3 through B33. B3 through B33. So we're going to find the average of B3 through B33, and we find out that if we round it to 4 decimals, we get 0.1598. The next thing we need to do is find our standard deviation. And we're going to use that to calculate UCL and LCL, which I'll explain in a minute. Now, we know these are samples because it tells us right there, so we're going to use the standard deviation, STDEV, of a sample. STDEV.S of a sample. And then we highlight again B3 through B33. Here we find our standard deviation is 0.1628. So putting those two together, we found our average first, and then we found our standard deviation. So we have a p-bar of 0.1598, standard deviation of 0.1628. Our next step is to find our upper control limit and our lower control limit. Now, we're using the assumption of a normal distribution, which we can do for several reasons. Number one, because our sample is at least 30 big. Number two, because if we were to take the portion defective minus the portion not defective, plus the portion not defective, we multiply that together, we get all of the rules that are necessary for us to be able to assume a normal distribution. Now, if you recall from your statistics class, you remember that that 99.7% or 0.997 of all of our data is going to fall within plus or minus 3 standard deviations away from the mean. Okay? So we're looking for a number that is equal to plus or minus 3 standard deviations away. All right? Well, the way we find that is we're going to say the UCL is going to be the mean plus 3 standard deviation. The LCL is going to be the mean minus 3 standard deviations. So let's plug those formulas in. We're going to say equal P bar plus, open parentheses, 3 times the standard deviation. And again, we're finding the mean plus 3 times the standard deviation to find the UCL. To find the LCL, we simply say equals the mean minus 3 times the standard deviation. Now, interesting thing about a P-chart is that it's not possible for you to have a negative LCL. You think about this for just a moment. If you look at day 2, we're saying that the portion defective, in other words, the number of parts that is defective is 0%. How are we going to come over here and say the average or the lower control limit of that is negative 33%? Well, that's just not possible. So the way we fix that is we're going to modify our formula by using the min formula. So we come between the equal sign and the H2 and we put in the word min, M-I-N, open parentheses, of 0 or our formula. And then we close the parentheses here. So what we're telling Excel to do is to give me either the minimum of, that should be maximum, not min. The maximum of 0 or the formula. Now what that does is Excel will now look at it and say, all right, let me calculate the formula. If that number is greater than 0, then I'll put the number in. If the number is less than 0, then I'll put in 0. Okay? So, now it seems I've made a mistake and it looks like all I did was forget a parenthesis. So let me double click so that you can see the formula one more time. As a matter of fact, I will highlight it, copy it, and I will paste that formula for you right here so that you can see it and take a screenshot. Let me do the same thing here as well. Alright, and don't forget your equal sign like I did. Alright, so here are the two formulas for the UCL and the LCL. All we've done is taken 3 times the standard deviation and added it to the mean. Here we took 3 times the standard deviation, subtracted it from the mean, and then asked Excel to give us either 0 or that number, whichever one was the highest. All right. Now, once you've done these formulas, if you use the Excel spreadsheet that I gave you, you will see that all of these numbers just fall into place for you. That's because I've already set it up for you. If you're following along at home and you plug these numbers in, then all you have to do is make sure that you go to this number, make it an absolute reference. Same thing here, and the same thing here. Okay. All right, so now we have our sample, we have a portion defective, LCL, P-bar, UCL. Go ahead and save your document. Make sure that you don't lose your work. Okay, so the next thing we need to do is go ahead and construct our P chart. It's a simple thing. All we need to do is highlight from A2 down to E33. From A2 to E33. We're going to insert recommended charts, and the very first chart is the one we want. Let me do that one more time. So I highlighted from A2 to E33, insert recommended charts, and the very first one is the one we want. Now, I'm going to highlight that and bring it up to the top a little bit so we can see it. Let me expand it just a fuzz so that you can understand what we're looking at. Okay. Now, for those of you following along at home, you'll see that my font size is 9. Well, I want to go ahead and increase the font size for the entire project so that you can see it on your screen. I'm going to go ahead and increase it to font size 20. And because I had the entire chart highlighted, then we have exactly what I need. You'll notice that my samples along the bottom correspond with the sample numbers here. You'll notice that my portion defective corresponds with each of these. The blue line represents the portion defective here. The red line, the LCL, represents the 0 line. My P-bar is going to be my average number, and then my UCL is going to be at the top. Alright, so the first thing I want to do is get rid of the grid lines that Excel puts in there, because I don't want us to confuse our grid lines for the lines we drew. So I'm going to highlight one of the lines and just press the delete key. The next thing I want to do is give my chart a title. Now obviously, because we can see the title to the left, I'm simply going to call it a P chart. Okay? You can call it whatever you want, but I call it a P chart. The next thing I need to do is take this line, and I want to change those markers from lines to dots, because there is no sample between 1 and 2 or between 2 and 3. It's sample 1, sample 2, sample 3, and my chart needs to reflect that. So I'm going to right click the blue line. I'm going to format the data series. Actually, I'm going to go to change chart type. And where it says XY scatter, I want to make that a scatter plot. So let me go through that one more time. Right click your blue line, the one that's for the portion defective. Change chart type. Go to XY scatter and just make it a standard scatter plot. When you're done, it will look like this. Okay. Now Excel automatically wants to give it another axis, and you'll notice that I have eliminated that, so I don't need this secondary axis over here. This number and this number represent the same thing. So let me just eliminate that guy and get that out of the way. Alright, well now that we've eliminated the grid lines, we don't necessarily know exactly where these lines are, so I need to add data labels to them as well. So I'm going to take the purple line, I'm going to click the line once, then click it again, so that I'm highlighting just the end point. Then I'm going to right click and add a data label at that point. You'll notice now that it gives me 0.65. So I know my upper control limit is 0.65. If you choose to, you can change the color to match the line, which is always a good idea. For the green line, I'm going to do the same thing. Left click again so that I'm selecting just that point. Right click, add data label. Pull it down slightly or up, either one. Just get out of the way. I'm going to change it to that lime green color to match the data label. I think it's, I don't know, we'll just make it that color. It's kind of ugly, huh? Let's make it the other green. There we go. Whatever color you choose to make it. If you want, you can even change the line color. That's fine too. So, all right, we can make that guy orange. Make this guy orange too. Whatever we want to do, it's up to you. Now for the red line, we're going to do the same thing. Right click, add data label. Notice that data label is 0. Going to change the color up here to that bright red or brick red color, and away we go. All right, go ahead and save your work again. Make sure you don't lose any of this. I'd hate for you to be through all of this and then have a problem. Okay. All right, now there's a couple of things we want to take a look at here, right? With our chart, we want to look and say, do we see any data points that are out of control? And if so, where are they? Well, the first one we notice is this guy right here. Our upper control limit is 0.65. In other words, the upper control limit tells us that 2/3 of our product is going to be defective, and this dude up here is way higher than that. It's 0.69. So I'm going to click that, and I'm going to change the color of this one to represent something else. It doesn't matter what color you make it. Let's just make it red, all right, so we can clearly see it, right? But in addition to that, I also want to make it stand out. So I'm going to go to Shape Outline. For the weight, I'm going to make it like 3 points. So it's really heavy. See that? Okay. So you can do whatever you choose to do for that. Okay. However you want to make it, just make it stand out. I just made it red, and there we see. Okay. All right. But are there any other issues that we run into? Well, anytime you have 3 or more data points going in the same direction, we call that a run. Okay? Here we have a run that's moving in the wrong direction, but it looks like management caught it. It looks like somebody was paying attention and they looked and said, hey, that's a problem for us. Let's go ahead and get that under control. So from day 18 to 19 to 20, we see that we're having a run, and that's out of control. Okay? They brought it back under control, but then around the 25th it jumped out of control again, back down to the 26th, and then it looks like we're having the same issues again. Right? Over here, this guy's out of control as well. Now, you say, well, Joe, it's underneath the purple line. It's beneath the upper control limit. That's true. Here's the problem, though. If we continue to let this go, it's going to be out of control. It's going to be an issue. Okay? In addition to that, these numbers that are above the line here are considered to be a cluster. Anytime you have 3 or more that are above the line, then that's an issue as well. What we want is this nice consistent line that's below the average. We want to, because what we're trying to do is pull down the average proportion defective. And if we didn't have this outlier, this guy up here, if we didn't have this run, our portion defective would be much lower than 16%. On day 2, we had 0% defective. Over here on day 6, we only had 4% defective. Now you think about a company like Amazon. 4% defect rate on 100,000 orders going out the door is significantly low. I mean, that's a pretty good number. That's where we want it to be instead of up here at 69%. That is just not acceptable at all. So this is the reason why we look at our statistical process control charts and we pull them every day. The gentleman or the lady who was running the shift on the 18th and 19th, and then finally over here, letting us look, we've got a problem here, so that needs to be brought under control. They caught it quickly and they brought it back under control. Okay, so who knows, there may be some issues or whatever, but now that we've seen that we have an outlier, we have two runs in our chart, the next thing we need to do is we need to figure out what's causing these. Well, this is what I want you to comment on. Think about a company like Amazon. What's causing them to be out of control? All right, let's just use them as an example. So we'll say, assume this is Amazon.com, and think about what they would be. Now, it may be any company or whatever. It may be Domino's or whatever. But let's just say, assume this is Amazon.com. So think about what portion and what might be causing that to be out of control, right? All right. And finally, what we want to do is look at the Process Capability Index. The Process Capability Index that we're going to use is called the CPK Index. Now, we use the CPK Index because us changing the portion defective to get, the LCL number to reflect the 0 means that we now cannot assume that it's normally distributed. In other words, our bottom line, the LCL, is much closer to the mean than the UCL. This number is no longer 3 sigma away from this one, therefore we can't assume a normal distribution anymore. So we use the CPK index to look to see which one that we're looking for. So we're going to look for the minimum of the UCL or the LCL and see what the difference is, and that will tell us what our Process Capability Index is. All right, so the first thing we need to do is we need to figure out what our minimum number is going to be. Let me go ahead and increase that font size there so you can see it. So we look for the min number, we look for the max number, and then we'll compare the two together. All right, so we're going to use this formula here. UCL minus the mean divided by 3 standard deviations. So we're going to say open parentheses UCL minus the mean, close parentheses, divided by, open parentheses again, 3 times the standard deviation. Okay? And this is the number you should get. It should be 1. We know that. Okay? Now, think about what we just did there. Okay? If to get the UCL, we multiplied it times the P bar plus 3 times the standard deviation. To get the min here, right? Excuse me. We simply took the difference and divided by 3 times the standard deviation. We reversed the process, so obviously it should be 1. Okay? To find the next half of this, then we should look to see what the difference between the mean minus the LCL divided by 3 standard deviations is. So we're going to say equals mean P bar minus LCL divided by, open parentheses, 3 times standard deviation. And here we're going to get 0.33. Okay. Now I have these backwards. This is our max, our UCL, and this is my min. I apologize about that. Just fix that mistake. What we want to do now is find the minimum of those two numbers. So we're going to say our CPK, I'll do it this way. All right, copy that, paste that down there. So our CPK is going to be equal to the min of these two numbers. All right. And obviously it's going to be 0.33. Now, let me do you a favor here. Highlight these numbers. I'm going to say equals. Now, in order for you to put this formula in, you put in an apostrophe in front of the formula. So I'm simply going to paste that in. Okay. And I'm going to do the same thing here. All right. And then to find the minimum of them, you say min of the two numbers together. Okay? All right. Now, let's answer the question, do you think the controls are too tight? Well, the answer is yes. Let me tell you why I know that. If the CPK index is exactly 1, then the process is perfectly capable. That means that it matches what you're trying to get it to do 100% of the time. So let me jot this stuff down for you, okay? If our CPK equals 1, then this is perfect capability. In other words, that means that it's able to do exactly what you want it to do all the time. Okay? So far, so good? Okay. If, on the other hand, our CPK index is less than 1, then that means that the process is incapable of handling the load. Okay? So here's what we're saying. If it's less than 1, then the CPK index cannot do what you're asking it to do. That means that you're going to end up with mistakes, and that's okay. You can have a CPK index that's less than 1 if you're on a deadline or if you're rushing or if things are trying to get there. Let's say it's Amazon and it's Christmas season. Well, their CPK index is going to be out of control. We know that. It's just not going to be what it needs to be, but that's because they have a Christmas rush and they're trying to get it, and for 1 or 2 days they're willing to accept that. Okay? In other words, in this particular instance, all right, well, let me just go ahead and finish this up. If our CPK index is greater than 1, then we have another issue. Now, this is a problem as well. This means that the process can handle more. Now, this is obviously the ideal. You want perfect capability. It very rarely ever happens, however. Okay? There's too many variables to consider. There's just not enough stuff that you're going to be able to handle. You just don't know when things are going to happen. Okay? The best of us very rarely ever manage to get perfect capability. What you want in an ideal situation, what you most of the time are going to end up with, is a CPK index that's greater than 1. This is what you want. You don't want to run your process at 100% capacity. You want to have excess capacity. You want to have more utilization. What you never really want to have, if you can help it, is a CPK that's less than 1. There are rare occasions when you have to do it. That's understandable, but you don't want this to be your, this is not something that you're interested in doing long term. If that happens to your organization, then you seriously need to consider changing or increasing your capability. All right. So we take a look at our CPK index, and we can clearly see that the process is incapable here. The CPK index is less than 1. That tells us that the process is incapable of handling the load. Now, what this tells me is that, so the first person here, the first portion they found was here, so on and so forth. But as we start to add more to the load, the process is not capable of handling it. We need to either increase capacity or reduce the load on the system. So the CPK index is 0.33. That means that it can handle the load about 33% of the time. This is why we end up here with a portion defective of about 69% and why our upper control limit is about 65%. This is way too high for a P chart. It's just not going to happen. What we need to do is figure out a way to fix all of this and make sure that at the end of the day we end up with a process that can handle more. We can always add more work to the capacity. Okay. All right, so at the end of the day, when you put all of this together, what can we do? Let's say it's Amazon. Well, one of the things we can do is add more shipping. We could add more to, our, maybe we could just slow down the process a little bit. Maybe we could stop taking orders. Probably not going to happen at Amazon, but let's just say that's just something we could do. What we really need to do is probably add more capacity. We want to grow as a company. So, all right, now, put all of this together, answer the questions for me, and you'll be okay. I hope you enjoyed the video. Have a great day.